Hello, welcome back, guys. We're gonna be learning about exponents. Some quick reminders. Go ahead and turn this on Google Classroom, and it's due by Sunday night by 11 p.m. Um, I'm gonna go through this through PowerPoint. So if you ever need to stop and rewind, especially considering I have things laid out already, please do so. So again, you might have a lot of writing to do, but you have the advantage to pause and rewind as much as you can. Okay, so just keep that in mind. All right, so exponent basics. Again, this is a concept that you should be familiar with. It's something that you've learned before, but again, we just want to reintroduce this so you have a good understanding of it. Here is just a quick example. We're going to go ahead and label what each of these actually mean. What A in this case actually is, again, forgive me for my handwriting here, but this is my base. A is my base, and here, this guy right there, is my exponent, okay? My exponent tells me, well, I'm going to multiply by the base to itself however many times. For example, in this case, it's multiplying its base, again, however many times the exponent tells me to do. Okay, that's its job. So if I have 3 to the second power, that 2 is telling me, hey, I want to multiply this base 2 times to itself, right? So 3 times 3, okay? Some other examples, again, I've got 4y taken to the third power, okay? This exponent is telling me I'm going to multiply 4y. Again, 4y is my base. It's included within parentheses. I'm going to multiply it by itself to 3 times, so 4y times 4y times 4y. And in this example, well, I have x minus 3 as my base and 2 as my exponent. So again, my exponent is telling me I'm going to multiply my base to itself 2 times. Okay? All right, so 2 properties. There's a bunch of rules. There's about 7 rules you got to remember when it comes to exponents. The first one is the 0 exponent property, and then the next one is the negative exponent property. Okay, pretty simple to kind of go through or to learn. Okay, so as far as the 0 exponent rule, that's anything raised to the 0 power is going to be equal to 1. So for example, a to the 0 power is going to be equal to 1, right? I can take anything to the 0 power. It's going to, at the end of the day, it's going to be equal to 1. So for example, I've got 100 taken to the 0 power. That would end up being 1 as an answer. Our negative exponent rule, okay, if we ever have a negative exponent, we've got to take the reciprocal of our base, and then once we take the reciprocal, we can turn that negative exponent into a positive one. Okay, so this definition, I wouldn't really, you can basically, I want you to kind of learn through these examples. So for example, I've got a to the negative n power. Well, this negative exponent, to make it positive, I'll have to find the reciprocal of a, which is 1 over a. Okay, and once I find the reciprocal, I can make this a positive exponent. Okay, so same thing here. I've got a over b to the negative n. Okay, to make this a positive exponent, I'm going to have to flip or find the reciprocal of a over b, which is b over a. And b over a to the n power would be my answer. Again, so just some real life examples. You might learn a little bit better with these numbers. So for example, I've got 7 to the negative 2 power. Well, again, I've got a negative exponent, and we don't like to deal with negative exponents. We're positive people. To make it positive, we have to find the reciprocal, and once we find the reciprocal, we can then make it positive. Okay? Same idea. Again, 3 over 2 to the negative 4. I have to make it to make it look positive, to make it the exponent positive, I've got to find the reciprocal, which in this case is just 2 over 3. All right, some quick examples. So I've got 2 to the negative 3 power. Well, again, we just learned if I ever have a negative exponent, in this case negative 3, I will have to flip the fraction, right? Or flip the base. So in this case, I've got 2. Well, that's going to turn out to be 1 over 2. And then you want to go ahead and make your exponent positive. So 1 over 2 thirds is, well, that would essentially just be 1 over 8, because 2 times 2 times 2 is just 8. Okay, in this case, in our second example, we've got 4 over 3 taken to the negative 2 power. Again, to make this positive, we'll have to flip the fraction, which is again 3 over 4. Okay, again, this is in parentheses, so make sure you have the parentheses again. But now we can go ahead and make that negative exponent positive, right? So this is 3 over 4 to the second power. Well, that's going to be 3 over 4 times 3 over 4, which, again, we know how to multiply exponents now. That's 3 times 3, which is 9, and 4 times 4, which is 16. All right, some more rules. Again, there's a bunch of them. You just kind of have to practice them, and you'll learn how to kind of go about these and when to apply it. Again, stop the video if you need to. Feel free. This is basically the video is there for you to take your time on. Multiplying exponents. Let's go through this first. Again, these 5 rules right here, you kind of have to, once you learn them, you can start applying them. Once you start practicing them, they'll be a lot easier. So when you multiply exponents, you're adding them, okay? So for example, I've got, again, the same base, and I'm multiplying these two values. What I do with the exponents is I essentially, like you see here, I add them, okay, to get my result. So for example, 4 to the third power and 4 to the second power. Well, again, I've got the same base, so I got the green light to add these exponents, which again, 3 plus 2 is 5. Dividing exponents, okay, so when you divide, you gotta subtract the exponents. So again, I'm dividing, I've got the same base, a, and I will subtract the exponents here. So a to the m minus n. So I've got 3 to the 7 divided by 3 to the second power. Again, all I'm doing is subtracting the exponents. So that would be 5. Power to a power. Again, when you raise one power to another, then you're going to multiply. Okay, so I've got a to the m to the n power. Well, that would essentially just be a to the m times n. And again, I think these real number examples make more sense. So I've got 4 as my base. That's being taken to the 4 power. But it's also being taken to the second power, right? So I'm going to multiply these two, and I'm going to get a result of 4 to the 8 power. Okay, so when you take power to a power, I'll end up multiplying those two values. In this case, I get 4 to the 8. Power of a product. Okay, so to find the power of a product, apply the exponent to each factor. So I would actually encourage you you can actually go back and forth just like these examples. But in this case, I've got a times b to the m. This exponent should be applied to both a and b. And that's exactly what it's explaining here. So again, I've got 4 times x being taken to the third. So that means 4 gets a power of 3, and also x gets a power of 3. Okay, and when you start simplifying that, you end up getting 64 x to the third. Okay, in power of a quotient, again, same idea really. I've got 3 over 5 to the second power. That means 3 gets a power of 2, and 5 gets a power of 2. Okay, so 3 to the second is 9, 5 to the second is 25. Again, each of these, your numerator and your denominator, both get a power of 2. All right, so just some examples. I've got the following. So I've got 2x to the third times negative 5x. Okay, so first of all, treat your numbers like numbers, right? So I'm going to go ahead and say, well, 2 times negative 5 is going to be a negative 10. So let's get that out of the way. And then I have x to the third times x. Okay, so notice I have x to the third times x. Well, we know when you're multiplying exponents, you got to add them, right? Remember, there's a 1 that you just don't see here, a 1 exponent for this x. So if I'm multiplying these two exponents, or these two numbers, I have to add the exponents. So you end up getting negative 10, of course, but x to the fourth power. Okay, so this would be your final answer here. Your next example, I've got ab to the fourth power over b to the 7. Again, this power of 2 goes to everything. It goes here, it goes there, and it goes there. Okay, so figure out what a to the second power is. Well, that's pretty easy. That's just a to the second power, right? B to the fourth power raised to the second power. Well, b to the fourth to the second power, again, we're multiplying exponents. So that would be b to the 8, okay? And then b to the 7 to the second power, well, that would just be b to the 14th power. Again, power to a power, we multiply. We're still not done yet, right? Because essentially what we could do is we got b to the 8 up top, right? And we have b to the 14th on the bottom, right? So we want to go ahead, I can't find my mouse here. We want to go ahead and subtract these two, right? So we have, let me put this in yellow. So we got b to the 8th and b to the 14th, okay? I've got the same base, I'm going to subtract these exponents. So 8 minus 14, let's go ahead and do that. So 8 minus 14, that would be negative 6. So I have a to the second, and I have b to the negative 6 power. Because again, 8 minus 14 is negative 6. Okay? Again, don't leave your answer like this because we do have a negative exponent. Okay? Well, how do we change that around? Well, we've got to basically flip what I have here. Okay? So that would essentially be a to the second over b to the 6th power. Okay? So this would be your final answer. I can't simplify anything more. So that would be your final answer there. Okay. So these are your practice problems. Go ahead and give those a try. Okay. We will practice these in class, and I'll explain furthermore on how to develop these exponents just from here on out. Okay. So go ahead and try these practice problems first, and then submit your notes for this weekend. All right. Okay. I'll see you guys next week.